Hello, student. We already have 4 lectures on matrix theory, so we have covered almost the theorem portion. Now, let's discuss some problem one by one. Okay, so I have seen, I think, for last 4 to 5 year previous year's paper. After that you will see most of them are like common. Okay, so I have seen, I think, in each year maybe 7 questions are coming. Okay, you may check this type of problem and that are very easier. Okay, so let's discuss the first one. Okay, so let me add a new page. Okay, so first problem, find all real values of alpha for which the rank of this is 2. I think that is missing, sorry, is 2. Okay, so how to find this type of problem? Basically, either you can think in this problem 3 order minor rank is not there, right? So from there you can say that, you see, this is also a 3 order minor, so this determinant should be 0, right? Otherwise rank should be 3. So you can write, since the rank is 2, so all the 3x3 order minor determinant should be 0. So you have 1 1 1 2 minus 1 alpha 7 1 alpha square. This determinant if you find, so basically minus alpha square minus alpha minus 1 common, then 2 alpha square minus 7 alpha plus 1 into 2 plus 7. So basically from there what you are getting, minus 3 alpha square minus alpha minus alpha plus 7 alpha, that is plus 5 alpha plus 9, right? Okay, I think there is some mistake. Okay, so I modified this, so you have this type of thing. So you just take 3 common, so minus alpha square plus 2 alpha plus 3, right? So 3 into, if you do the middle term factor, so what we are getting, minus alpha square, nothing, minus alpha plus 3 alpha plus 3, right? So from there you have 3 into minus alpha common, alpha plus 1 plus 3 into alpha plus 1, so 3 into alpha plus 1 into alpha plus, sorry, this type of thing. So when it should be 0, so basically you just write now for alpha is equal to 1 and minus and other value is minus 1 and 3, right? The determinant the minor is 0. Minor is 0. So then obviously you see, then you have to go for the two order determinant, and you see for two order determinant, obviously if you consider this minor, so obviously then rank is your 2, right? So in this way you can try. Okay, there are so many way to do this type of problem. Okay, I can, yeah. So now I am doing in another method. For example, suppose you are doing row column operation. Okay, so if you do row column operation, I'm not show the step. Okay, this is your job, how to do this type of problem. To minus 1 alpha 5 7 1 alpha. Now you just do some row operation. Okay, row operation that you know well, right? We have discussed. You can do just normal equivalent form. Okay, not RREF. So basically you can convert this thing into this type of matrix. Okay, so you just make this type of thing. Now after that step, when this rank should be 2, so obviously you should get a 0 row. So from there you have that alpha square minus 2 alpha minus 3 is 0. So this is equivalent to alpha minus 3 into alpha plus 1. Actually same you are getting. So alpha is equal to 3 and minus 1. Okay, so in this way also you can do, but you have to find what are the row operation. Okay, this is very easy, right? First you try to make it this is 0. Okay, whatever you are getting here you just keep at this, then you try to make this is 0. Okay, after that step you try to make this thing is 0, then you will get this thing. Okay, no issue. I'm going to the next question. So next question is find the rank of this when x not equal to 0 and x equal to not equal to minus 1, and then you have x equal to minus 1. Both case you have to discuss. Okay. Okay. So for this problem, whenever your your x not equal to minus, suppose x not equal to minus 1. Okay, so then obviously you see 3 cross 4 matrix this is, right? So obviously its maximum rank 3 possible. Okay, so if you find that a 3 order minor which determinant is non-zero, that's it, right? So just you just consider the determinant of, suppose you are considering this above 1, this is your choice. Now consider the 3 cross 3 minor. Suppose you are considering this one, x minus 1 minus 1 minus 1 x minus 1 minus 1 minus 1 x. Okay, this is x, okay, not n. So after that step you just find a determinant. Okay, so x into x square minus 1 plus 1 into minus x into plus 1, then minus 1 into 1 plus x. So you have x cube minus x minus x plus 1 minus 1 minus x. Just to check I may be doing any wrong. Okay, so I'm not getting any constant. Yeah, there is some minus 1 it will be, so I think this is minus 1. Okay, so from there you have x cube, I think minus 3x minus 2, right? So this type of thing you are getting. So for x not equal to minus 1, if you put this value, so what you are getting, obviously you have to factorize this thing. You just do some vanishing factor where it is 0. Minus 1 is a factor, right? Minus 1, yeah, minus 1 is a factor. So you just think from there, minus 1 is a, x is equal to minus 1 is a factor, that means x plus 1, right? So x square minus x square minus x minus 2x minus 2. From there you are getting square into x plus 1 minus x into x plus 1 minus 2 into x plus 1. So you have x plus 1 common, then you have x square minus x minus 2, right? So from there if you do again middle term, so x plus 1 into this is will be x plus 1 into x minus 2, right? So this type of step you do yourself. Okay, so still they asked only for x not equal to minus 1, so but there is a possibility the x value may be 2, right? So then you have to consider that if your x equal to 2 value, what is the rank? Okay, that you have to check. Okay, so we can say from here, if x are not equal to minus 1 and 2, so then rank is 3. Okay, now for x equal to 2, what you have? For x equal to 2, you can substitute the value, right? X equal to 2, what you will get? I think 2 minus 1 minus 1 minus 1 2 minus 1 minus 1 minus 1 2 1 1 1. Okay, so basically the above 3 cross 3 is 0. So you may check, suppose you are considering this one, so what is the determinant? Okay, now consider the minor. So for x equal to 2, the matrix becomes this one, right? This one. Now consider the minor. This is actually 6 marks problem, I think. Okay, so not just one liner, two liner problem. Okay, so minus 1 2 minus 1 minus 1 minus 1 2. I am considering the lower 3 cross 3. Okay, 1 1 1. You just check the determinant, what you are getting. Minus 1 into minus 1 into minus 3 minus 2 into minus 1 minus 2 minus 1 into minus 1 plus 1. So this is 0. Okay, above you have 3 and you have, I think, plus 6, like 9 not equal to 0. So rank is 3, right? rank is 3. Now you have to check for x equal to -1. So x equal to -1, the matrix becomes you just check what you are getting. -1, -1, -1, -1, -1, -1, -1. Oh, you see the nice thing, right? You see all the matrix row are actually in 3 actually totally identical, and the fourth one is also your multiple of -1, right? So for this type of thing, just do some row operation. Okay, so you will see you will get only one matrix, right? One row. You just show the transformation, nothing else. Okay, so suppose you just do r2 dash equal to r2 minus r1. Okay, r3 dash is equal to r3 minus r1. Okay, r4 dash is equal to r4 plus r1. So if you do this thing, what you will get? So rank what? Only one row. So 1. Okay, so in this way you have to do. So this is not any one way that you can do. Okay, you see, sometime we are going for minor, sometime we are going for transformation. Okay, so this is your choice. Let's see the third question. So first, second down. Third, find the characteristic equation of A and show that the matrix A satisfy its characteristic equation. So this type of problem you can do easily, right? So basically what you have to do, okay, I am doing writing here. So first you have to find the determinant of A minus lambda, right? So determinant of A minus lambda I equal to 0. So first you have to find, so 1 minus lambda minus 1, 2, 2 minus 2 minus lambda 1, 3, 5, 6 minus lambda. This determinant is 0. So this is your job. Okay, you find yourself what is the determinant. I am writing the direct answer. So minus lambda cube plus 5 lambda square plus 15 lambda minus 75 equal to 0. So this is you are getting. So you can say the characteristic equation is you can write this form also, or you can multiply with -1, because we prefer the equation whose the highest power coefficient is 1, right? So that's why, nothing else. Okay, so this is your equation. Now it satisfies its characteristic equation, and you know it should satisfy, right? By which theorem? Mainly the Cayley-Hamilton theorem. Okay, so what you have to show, basically you have to find the matrix. First A is given, so then try to find A square, that is A star A into A, find that matrix. Okay, then find AQ equal to A square. Already you have find this one, you just substitute here into A, you will get some matrix. Okay, then substitute in that form. Now check. This is very easy question, right? 5A square minus 15A plus 75, not 75, this is 75I. You just check and you should get the 0 0 0 0 0 0 0 0 0. Okay, so this is just a very easy question. Okay, next, this is done. Now going to the next question, and that okay, so first portion is done, so I can delete this page. 1 2 3 then 4. Okay, so here the problem is, you know what do you mean by orthogonal matrix? Orthogonal matrix, this is a part of in your class 11 or 12. So basically A is said to be orthogonal if your A into A transpose is equal to identical, that type of, or A transpose into A if you do, so that you should get identical, right? Now the thing is, whenever you have this type of thing, if you know whenever you have determinant of A transpose, okay, this is equal to determinant of A also. Okay, so remember, whenever you have orthogonal matrix, the determinant of A will be either 1 or -1. Why? If you take determinant both sides, what you are getting, A into A transpose is equal to determinant of I, that is 1, right? And you know determinant of AB equal to determinant of A into determinant of B. Okay, so from there you have determinant of A square, right? This is equal to 1. So from there you have determinant of A will be plus minus 1 in this way. Okay, so whenever you have this type of thing, you can say that orthogonal matrix have determinant 1 or -1. Okay, okay, so basically you know this type of thing. Okay, so here you read the problem. A and B two real orthogonal matrix such that determinant of A equal to determinant of A plus determinant of B equal to 0. So I am writing the solution from here. Okay, so date A plus date B is 0. That means you can say date of B equal to minus of date of A, right? Okay, actually you see, it is not that A plus B is singular. That means your determinant of A plus B, you will say date A plus date B. This is not valid. Okay, don't mistake. Determinant does not have any this type of property. Yes, it is for multiplication, it's hold determinant of A into B equal to date A into date B. That is fine, but this is not hold. Okay, so basically you have to show A plus B is singular. Okay, so for this one you have to take help from A transpose. If you have to multiply, then it will be okay, I think. Okay, so okay, so date B is equal to minus date A. Okay, now if you find what is the determinant of A transpose B, okay, so this should be -1. Tell me why? Because determinant of A is your 1 or -1, right? So if your determinant of A is -1, then date B will be +1 in this way. Since A and B orthogonal, that is determinant of A equal to determinant of B equal to +-1, that you know, that is therefore. So from there you have this type of thing, right? And you later will learn that whenever you have this type of thing, orthogonal matrix actually eigenvalue lies on the unit circle in the complex plane. Okay, and for this one it has a eigenvalue of that is -1. It is a eigenvalue of this type of matrix. Okay, so that is a property that an orthogonal matrix A transpose B is also orthogonal. You can easily check. Okay. Okay. A transpose B is an orthogonal matrix with determinant -1. Okay, that is, you can say that there exists a x not equal to 0 such that what, A transpose B x will be -x, right? -1 is -1. It is that means it has a eigenvalue, so it has eigenvalue -1. Therefore this is a little bit tricky problem. Okay, A transpose B is equal to I. So this type of thing you can write as A transpose Bx equal plus I into x equal to 0. So from there you have A transpose B plus I into x equal to 0. So now multiply with A from the left hand side. So what you will get, B plus A x equal to 0, right? Left. So if you have this type of thing, so you can say that 0 is an eigenvalue of that matrix, right? So this implies that eigenvalue of the matrix, so determinant of A plus B will be 0. Okay. Okay, so today we'll so this is your fourth question, right? What is your fifth? Okay, fifth is easier. This fourth one little bit tricky. Okay. Okay, so okay, before going that, I just forget, I think we have discussed or not. Suppose you have a matrix A11, A12, A21, A22. Okay, now if you find a characteristic equation, okay, so what you will get, basically A11 minus lambda, A12, A21, A22 minus lambda, right? This is equal to 0. Strict equation. So from there you will get, if you just do this type of operation, you just break this thing and you see, you will get this type of thing. Okay, so this type of thing you can say this is equal to lambda square minus trace of A into lambda plus determinant of A equal to 0, right? So for 2 cross 2 matrix you have this type of result. Okay, and you know, whenever you will learn the polynomial, the product of the roots of this equation, suppose you are considering this equation, so what is the product of root? So basically if you have lambda 1 and lambda 2 be 2 roots, then what you have, lambda 1 into lambda 2 will be the last one, right? So you can say this is your determinant of A, and your lambda 1 plus lambda 2, right? This should be your negative of that, right? So this should be your negative of that coefficient. So negative of negative, that means your, this should be trace of A. So this type of result you have. But for 3 1 also you have lambda 1, lambda 2, lambda 3 should be determinant of A, and lambda 1 plus lambda 2 plus lambda 3 will be trace of A. Middle one will be some product of I think in polynomial we will discuss this type of thing. So but remember the if A be n cross n matrix, okay, and lambda 1, lambda 2, dot 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 lambda n are the n eigenvalue, then you have lambda 1 into lambda 2 dot 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 lambda n is equal to 1, sorry, determinant of A. Lambda n should be trace of A, right? So this result you need. Okay, now I am going to the next one. So if your lambda is an eigenvalue, so 1 by lambda is the eigenvalue of A inverse, right? So this is very easy. So basically if lambda is the eigenvalue, so you have x equal to lambda x, right? Lambda not equal to 0 is an eigenvalue. So there exists x such that x equal to lambda x. Now if you have multiply with A inverse, x equal to lambda A inverse x, right? So you can say A inverse x is equal to 1 by lambda into x. So what you have? 1 by lambda is an eigenvalue of A inverse, right? This is our fifth one. Okay. Now for the sixth one, suppose you have two eigenvalue, lambda 1, lambda 2, and v1 be the corresponding eigenvector. So you have A v1 equal to lambda 1 v1, okay, and A v2 equal to lambda 2 v2. Now remember here it is symmetric, that means A transpose is equal to A. This type of thing already you have, okay. Now suppose you are doing A into v1 transpose into v2, because basically you have to find the product of v1 v2, okay. So basically this type of thing you will learn later, that is called scalar product. For example, if you have 1 comma 2 and 3 comma 4, okay, that means this is like 1 plus 1 into 3 plus 2 into 4, this type of thing, okay. So you have 3 plus 6, that 11, this type of thing, okay. Or you can say if you have v1 v2 one thing and v2, if you write in this form, so you can write this is v1 transpose v2, right? So then what happened, you will have one matrix in row form, other will be in column form. So then that is happening, right? So it's already 1 2 3 4, this is your 1 into 3 plus 2 into 4, like that, right? So that's why we are dealing with this type of v1 transpose v2, Okay, so what you have this thing, you know, this is your basically a v1 is equal to lambda 1 v1 transpose v2, right? Okay, so now again a v1 transpose v2, so this is you have, sorry, this transpose is above, so this is you can write v1 transpose into a transpose v2, right? So from there what you have, v1 transpose lambda v2, so sorry, a v2, that means your v1 transpose lambda 2 v2, right? So this is your lambda 2 into v1 transpose v2. Now you see both are same, so you can have lambda 1 v1 transpose v2 equal to lambda 2 v1 transpose v2. So from there you have lambda 1 minus lambda 2 into v1 transpose v2 equal to 0. So from there you have what you have, v1 transpose v2 equal to 0, since lambda 1 not equal to lambda 2, right? So this is also easy question, this one. Okay, so this is your 6th one. Now 7th one. Okay, okay, so this is you have to do, I just give you the corresponding form. No, this is not okay. So suppose you have this type of thing, you have to find the value of lambda and mu, right? So first your job is to consider the augmented matrix -4 2 -9 2 3 4 1 5 3 4 lambda mu. Okay, this type of thing you have. Now after that step you apply your row column operation, okay, in your echelon form you can find or anything. Okay, so in this way you finally try to get some zero type of column in the last row. Okay, so for example if you have -4 2 -9, just do the last one, you see these two element will be 0, so you have r3 dash will be r3 minus r2, so you have 3 4 1 5 0 0 lambda minus 1, you have mu minus 5. Okay, so you see if your lambda equal to 1 and mu is equal to 5, so this have the rank 2, right? And if it is, this is your 0 but this is not 0, then you have actually no solution. Think in this way, because what this implies, basically lambda minus 1 lambda minus 1 into z will be your mu minus 5. So if your one side is 0, other side is non-zero, so then you have problem, right? So for this one you require that this lambda cannot be 0. If lambda not equal to 1, okay, basically lambda minus 1 not equal to 0 imply lambda not is equal to 1, then unique solution. Okay, now next case, what's happen if your lambda equal to 1? So lambda equal to 1, then you see that this side will be totally 0. Now for this one you will have that 0 into mu 5, right? So lambda equal to 0, then you have two cases. If mu equal to 5, then you have infinite number of solution. Then actually you will have actually lambda a rank of av equal to 2. That means it has infinite many solution. And under this case, if you're this is under this case, okay, same case, we have two cases. If your mu not equal to -5, so you see this is like 0 is equal to 1, 0 equal to some value, non-zero, right? So then you have no solution. Then a rank of actually AV is actually your greater than rank of A. So no solution. Why? If you check, in that case their rank A will be 2 and in this case your rank will be 3. That is not consistency criteria. Okay, so this is no solution. So today we'll finish our class here. So we have discussed all the question from 2024. We'll take one more class for PYQ and see. Okay, you just you may have a screenshot from there and you can practice one by one. This is year 2023. Okay, then we have 2022. You see 7 question is coming in everywhere. Okay, and 2021 there is some syllabus change. Okay, linear transformation is not a part of that, so this type of thing. Okay, bye for today. We'll discuss in our next class.